The 2026 Stanford AI Index confirms that top-tier open-source models have reached performance parity with proprietary U.S. APIs. This parity means that defaulting to a major cloud provider is no longer the automatic choice. For many workloads, the convenience of an API now competes directly with models you can own and control yourself. The decision hinges on a specific calculation. Do you pay for frictionless deployment, or invest in local hardware for zero variable cost, hyper-specialization? Stanford data shows open-source and proprietary models intersecting in 2026, but cloud API long-context surcharges cause massive cost spikes. Conversely, local hardware risks standard servers buckling under 671 billion parameter weights, crashing unless utilizing efficient multipath MOE flows. Finding the right tool has nothing to do with global benchmark scores. It is entirely about matching the model's deployment architecture to your specific operational constraints. Proprietary APIs are built for power users and enterprise teams who need immediate deployment for complex knowledge work without managing servers. GPT 5.4 leads this category because it can natively control your desktop applications and coordinate multi-step workflows across your software tools. Plotting cost per million tokens against specialization, GPT 5.4 sits at the high end for desktop automation. Gemini 3.1 Pro anchors the lower cost end with its 2 million token context window. Comparing 100 million tokens, Gemini saves $140,000 annually, ideal for long documents, though you forfeit GPT 5.4's control. For developers specifically, GPT 5.3 Codex remains the standard for terminal-native workflows. Teams keep Codex over upgrading to 5.4 because it costs 30% less per input token and operates directly within command line environments. Across all these APIs, you have to watch your output token ratio. Models naturally generate verbose responses, and those output tokens cost 5 to 8 times more than input tokens, severely inflating your final bill. If your tasks are not time-sensitive, routing them through caching and batch processing APIs can cut those costs in half. Operating on the proprietary frontier requires strict discipline. If you aren't actively using an API-specific desktop, context, or terminal feature, you are bleeding budget on unused capability. If you want to protect your privacy and avoid monthly subscriptions, the open-source and local hardware route is your alternative. DeepSeek R1 is currently a leading choice for intense logic and mathematical reasoning tasks, matching top proprietary models in those specific domains. Plotting VRAM requirements against specialization, DeepSeek R1 sits in the high VRAM, high specialization quadrant, requiring 24 gigabytes of memory for its chain of thought steps. For constrained hardware, Gemma 4 drops into the low VRAM general-purpose quadrant, running at 85 tokens per second on a consumer laptop. However, the Gemma license contains strict usage policies and commercial restrictions. It is not true open-source software under an Apache 2.0 license. If you need scale without the cloud, the Llama 4 family includes the Scout variant, which processes a 10 million token context window locally. But if you operate in the European Union, Llama 4 presents a hard compliance roadblock. The acceptable use policy explicitly restricts multimodal rights for EU users. For developers who want to write code locally, Qwen 2.5 Coder 32B offers high-level programming capabilities with zero monthly cloud fees. Mixture of Experts architecture enables consumer hardware operation. The network activates a single specialized pathway of parameters, leaving the rest dormant to save memory. Success in the open-source space requires mapping the exact VRAM footprint and legal license of a model to your hardware and compliance realities. As these models integrate into enterprise infrastructure, securing them against prompt injections and data poisoning becomes mandatory. Research shows that large base models often perform poorly when tasked with evaluating security classifications. Because they are optimized for conversation, base models often generate long explanations instead of strict binary judgments. In benchmarking against the OWASP Top 10, this resulted in significant latency and total failure to flag critical vulnerabilities. This side-by-side performance scorecard illustrates the solution. While the base model struggles, specialized micromodels like the 1 billion parameter LlamaGuard variants deliver low latency and a 76% detection rate with strict safe or unsafe binary outputs. Relying on a massive generalized model for systemic security is a mistake. Organizations must adopt multi-model architectures where purpose-built models handle specific protective layers. Selecting your tool is a process of building a personalized matrix based on your constraints, rather than chasing whoever is at the top of a leaderboard. This decision tree flowchart maps the strategy. The first node asks, is data privacy mandatory? This splits your path into local hardware or cloud APIs. Following the cloud branch, your next question is whether you need desktop automation. If yes, you pay for GPT 5.4. If you just need to process high-volume context cheaply, you choose Gemini 3.1 Pro. Down the local branch, your hardware capacity is the filter. If you have under 16 gigabytes of VRAM, you run Gemma 4 or Phi 4. With 24 gigabytes or more, you deploy DeepSeek R1 or Qwen. Enterprise operators should combine these two paths. Run cheap local guard models to filter inputs, and reserve expensive proprietary APIs strictly for the complex reasoning tasks that require them. Independent developers with strong local hardware can drop API subscriptions entirely, relying on DeepSeek or Qwen to achieve expert-level coding. The most effective AI strategy for 2026 ignores benchmark hype entirely. You win by ruthlessly anchoring your tool selection to your exact budget, your hardware capacity, and your privacy